Okay, example number 1, an object executes simple harmonic motion whose displacement varies with time. So they gave us the the equation of displacement where x is in centimeter, t is in seconds. So we have to determine the amplitude, frequency, and period of the motion, velocity and acceleration of the object at any time t, and then the displacement, velocity, and acceleration at t equal to 2 seconds, and lastly the maximum speed and acceleration of the object. So in this case, let us compare this with the general equation. So firstly, x is equal to 8 sine 3 pi t, and then we have the general equation for displacement is a sine omega t. Okay, so for this one, we are gonna compare this with this lah. So A dia apa? A dia maksudnya based on this is 8 lah. So A amplitude is 8. Dia cakap X is in centimeter, so centimeter. And then we have omega, which is equal to 3 pi radian per second. Okay, so we have the information. So this is Roman 1, so we have the amplitude saja. So we have to find the frequency, which is omega equal to 2 pi f. So from here, f is omega over 2 pi. So this is 3 pi over 2 pi, which is equal to 3 over 2, which is equal to 1.5 hertz. Okay, so that is the frequency. And then lastly, we have to find the period, which is just 1 over the frequency. So 1 over 1.5 is equal to what? Is equal to 0.667 seconds. Okay? Right, lepas tu we have to find velocity and acceleration at any time t. So in this case, we actually have to find the general equation lah. Okay, so the relationship between velocity and time punya equation. So we know that v, the velocity, is the rate of change of displacement, dx over dt. So d over dt, aduh basar. So d over dt, x is what? X is 8 sine 3 pi t. Kan? 8 sine 3 pi t. So this is just differentiate ba, astaga. Okay, so let's differentiate this equation in terms of time. So kita bring forward 3 pi. So 8 differentiate sine dapat cos 3 pi t. Okay. Okay, lepas tu 8 times 3 berapa? 24 kan? So 24 pi cos 3 pi t. So this is the general equation for velocity. Tapi this is not the end. We have to write where v is in centimeter per second and t is in seconds. Okay? Okay, lepas tu kita perlu pula buat untuk acceleration. So acceleration is the rate of change of velocity. So dv over dt. So d over t over dt. V is 24 pi cos 3 pi t. Okay, so I'll differentiate this. You then get 3 pi, 24 pi. Cos, differentiate cos, kita dapat negatif ah. So negatif di depan, sin 3 pi t. Okay, so dapatlah negative 3 times 24 is negative 72 pi square sin 3 pi t. Okay, again we have to write where acceleration is in centimeter per second square and t is in seconds. Okay? Okay. Right. Cukup. Lepas tu kita perlu cari pula at time t, x dia berapa kan? Displacement and velocity and acceleration. So that is at t equal to 2 seconds. We have x is equal to 8 lupa sudah, sabar. Mana tu? 8 sine 3 pi t. So kita substitute je lah, t is equal to 2 seconds tu. So 8 sine 3 pi 2. Okay, this one I have to calculate. So 8 sine 3 times 2 is 6 pi. Okay, so kamu akan dapat the value equal to, we have to use radian lah. Mode change to radian equal to kejap ah. Why is it not the answer that I'm expecting? Okay, betul lah. So this x is equal to 0 centimeter. Okay. Lepas tu untuk velocity pula. So velocity tadi kita dapat 24 pi cos 3 pi t. So again just substitute the value. Cos 3 pi 2. So 24 pi cos 6 pi. Mesti guna radian lah. Kita akan dapat 75.4 centimeter per second. Okay. And lastly, we have to do for acceleration. So acceleration is negative 72 pi square sine 3 pi t. Okay. So substitute 3 pi 2. Dapat jawapan seberapa? Pi square sine 6 pi. So dapat equal to 0 juga. So this is 0 the second square. Okay. So that is the solution for question Roman 3. And then lastly we have to find the maximum velocity and then the maximum acceleration. So maximum velocity kita tahu formula dia is A omega. So amplitude is 8 centimeter. Omega is 3 pi. So we get 24 pi centimeter per second. And then maximum acceleration is basically just A omega square. So this is 8, 3 pi square. So this is equal to 72 pi square centimeter per second square. Okay, so that is the solution for example number 1.